Earthquakes and fault lines, cracks in the Earth's armor. Title: Earthquakes and fault lines, cracks in the Earth's armor. Introduction. The Earth, our home, is a dynamic planet with untold wonders hidden beneath its surface. Beneath the serene landscapes and vast oceans lie a network of fault lines, subtle evidence of the forces at work shaping our planet. Earthquakes, resulting from the sudden release of energy along these fault lines, are a stark reminder of the Earth's eternal movement and the cracks in its armor. In this article, we will explore the fascinating world of earthquakes, fault lines, and the impact they have on our lives. Understanding earthquakes. An earthquake, in simple terms, is the shaking of the Earth's surface caused by the release of energy in the Earth's lithosphere. While the causes behind earthquakes are complex, they can be primarily attributed to the movement of tectonic plates. The Earth's lithosphere consists of several large and small interconnected plates that are in constant motion. When these plates interact at their boundaries, they can cause earthquakes. Fault lines, the telltale signs. Fault lines, also known as seismic faults, are the visible indicators of plate boundaries where tectonic forces converge or diverge. These fractures in the Earth's crust can stretch for thousands of kilometers and are where most earthquakes occur. The movement along these fault lines can be categorized into three types: normal, reverse, and transform faults. Normal faults occur when the Earth's crust is subjected to tensional forces, causing one side to move downwards relative to the other. These types of faults are often found in regions where tectonic forces are pulling apart, such as mid-oceanic ridges or rift valleys. Reverse faults, on the other hand, result from compressional forces, with one side of the fault moving up relative to the other. These faults are common in areas where tectonic plates collide, leading to the formation of mountain ranges, such as the Himalayas. Transform faults, as the name suggests, occur when tectonic plates slide horizontally past each other. These faults are responsible for the majority of earthquakes in areas like the San Andreas Fault in California. Measuring the power, the Richter scale. To quantify the power and impact of an earthquake, scientists rely on the Richter scale. Developed by Charles F. Richter in 1935, this logarithmic scale measures the amplitude of seismic waves generated during an earthquake. Each whole number increase on the Richter scale indicates an energy release about 31,6 times greater than the previous number. For example, a magnitude 5 earthquake is 31,6 times more powerful than a magnitude 4 earthquake. The value of early warning systems. Earthquakes can strike with little to no warning, leading to devastating consequences. However, advancements in technology have made it possible to detect seismic activity before the destructive shock reaches populated areas. Early warning systems, like those implemented in Japan, can provide crucial seconds or minutes of advance notice, allowing people to seek shelter and potentially save lives. These systems rely on a network of seismometers and sophisticated algorithms to detect and analyze seismic activity in real time. Impacts and aftermath. Earthquakes have a profound impact on both the natural environment and human civilizations. The immediate effects include ground shaking, which can cause buildings to collapse, landslides, and tsunamis. Furthermore, secondary effects such as aftershocks, fires, and disruptions to vital infrastructure can compound the devastation. The long-term effects can be equally challenging, as communities often struggle to recover and rebuild after a major earthquake. Mitigation and preparedness. While we cannot prevent earthquakes from occurring, we can take measures to mitigate their impact and enhance our preparedness. Building codes, seismic retrofitting, and education programs play pivot. Our roles in minimizing the damage caused by earthquakes. By designing structures to withstand seismic forces and educating communities about preparedness and response measures, we can save lives and protect our built environment. Earthquakes continue to captivate scientists and researchers as they seek to unlock the mysteries of these powerful natural events. The study of fault lines and their connection to earthquakes plays a significant role in our understanding of the Earth's dynamic nature. Rising from the ashes. The aftermath of an earthquake presents a unique opportunity to learn and grow. The devastation caused by these events can be devastating, but it also serves as a catalyst for change and progress. And why communities affected by earthquakes have risen from the ashes, implementing stronger building codes and infrastructure to withstand future seismic events. The role of technology. Advancements in technology have revolutionized the way we detect and measure earthquakes. Seismographs, which once relied on paper and ink, have evolved into highly sensitive digital instruments capable of capturing even the slightest tremor. This technological progress enables scientists to analyze earthquake data more accurately, leading to improved prediction models and mitigation strategies. The human connection. Earthquakes are not just scientific phenomena, they also have a profound impact on human lives. The fear and uncertainty surrounding these events can be overwhelming, leading to anxiety and trauma. It is essential to prioritize mental health support and community resilience in the aftermath of an earthquake to help individuals and communities heal and recover. International collaboration. Earthquakes do not recognize borders, making international collaboration crucial in understanding and mitigating their impact. Scientists, engineers, and policymakers from around the world work together to share knowledge, develop early warning systems, and improve building practices. This global effort ensures that communities worldwide can be better prepared for future earthquakes. Public awareness and education. Education plays a pivotal role in preparing communities for earthquakes. Public awareness campaigns, school curriculum integration, and community drills are essential in empowering individuals to take appropriate action in the event of an earthquake. Ensuring that information is accessible and easily understood is crucial, allowing communities to make informed decisions and stay safe during an earthquake. Looking ahead. The future of earthquake research holds much promise. Scientists continue to refine prediction models, seeking to provide even earlier warnings and develop innovative approaches to reduce the impact of earthquakes. From improving building materials to implementing sustainable construction practices, The goal is to create communities that are resilient to seismic events. Final thoughts. Earthquakes serve as a reminder of the tremendous power and constant movement of our planet. By understanding the science behind earthquakes, the significance of fault lines, and the impact they have on our lives, we can better protect ourselves and the environment. Through continued research, innovation, and preparedness, we can pave the way for a safer future in the face of these natural events that shape our world.